Good morning, everybody. So you can see I'm in a new location. So if you hear the fish tank in the back, I apologize, but this is going to be a quick video on discussing mass versus weight and working on conversions. So if you did your homework last night and you had some trouble on it, make sure that you are correcting your homework and taking notes on this because it is going to be on your test and I want to make sure that everybody understands it. So let's jump into it. So weight is the measure of gravitational attraction that an object has to another object with mass, right? So the Earth has mass, we have mass, so we are gravitationally attracted to this Earth. Yay, right? So when I say it's a force of attraction, that's what I want you to solve for is weight. All right, so weight is a force of attraction. Mass is a constant. Okay, so wherever you are, whether you're on Earth, whether you're on the moon, whether you're on Jupiter, whatever, mass is a constant there. So the amount of material an object has does not change due to your location. So that would be the mass, right? The amount of matter that you are made up with or that object is made up with. Okay. So also on that PowerPoint yesterday with the notes, we were given these three conversions, right? So on Earth, 1 kilogram weighs about 10 newtons, and we're going to find out why in just a second. And then 1 kilogram weighs about 2.2 pounds. And the SI units for force are newtons. And again, the SI units for mass are kilograms. So let's go ahead and jump into our homework and go over some of the problems that I saw that we were having. So this is the first one here. Sorry, it took me a couple seconds to get to that screen. So let's go over it. So how much does a 1 kilogram bag of nails weigh on Earth? So the first thing I want to ask you is, what are we given in the problem? All right, awesome. We are given mass. So let's write down mass is equal to 1 kilogram. How do we know that we are given mass? Well, we're given 1 kilogram bag of nails. Okay, and we know that mass is measured in kilograms. And now we look at our handy-dandy equation. So weight is equal to mass times acceleration due to gravity, or weight is equal to m times g, where m is your mass in kilograms, g is your acceleration due to gravity, which is 10 meters per second squared. You can just ignore this other conversion. We're not going to use it. Okay, so g is meters per second squared. Okay, so we know our mass, and now we know g. So let's go ahead and write down g. So g is 10 meters per second squared, right? And now we have to solve for weight. So weight to us right now is a question mark. So in order to solve for weight, all we have to do is plug in what we know, right? Plug and chug. So W equals mg, where m is 1 kilogram in this case, and g is 10 meters per second squared. All right, so W equals 1 times 10, which is 10, and we measure the force of attraction, or weight in this case, in newtons. So if you have a kilogram meter per second squared, that is equal to a newton. All right, so we have a kilogram meter per second squared, so newtons here. And always just put it in newtons unless you are asked to solve for it in pounds. Then it's a totally different conversion, so you don't have to worry about it at this point, okay? But if you have weight equals mg, know that you are measuring your weight in newtons because it's a force of attraction and we measure forces in newtons. All right, sweet. Let's jump to the next one here. So Felicia, the ballet dancer, has a mass of 45 kilograms. What is Felicia's weight in newtons at Earth's surface? So again, what are we given in this problem? All right, it is the mass. So we start by writing down the mass. So mass is equal to 45 kilograms. And now we look back at our equation, right? So we need to have mass, we need to have g in order to solve for weight, which is what we are trying to solve for here. So we know g. What is g? Well, g is equal to 10 meters per second squared, right? It's that force of like the attraction of gravity, right? We say gravity in this class, but it's that attraction, okay? So we need to solve for weight. So weight right now is a question mark to us. So how do we solve for weight? Well, we rewrite our equation. W equals mg. And we don't know W, but we can plug in M and we can also plug in G. So M is equal to 45 kilograms. Woo! And we know G, 10 meters per second squared. Awesome. So now all we have to do is do the math. So 45 times 10, we get 450. And how do we measure weight or that force of attraction? Well, it's in newtons. So it would be the weight is equal to 450 newtons. So Felicia's mass is 45 kilograms. What was her weight on the Earth's surface? 450 newtons. Awesome. Let's go to the next one. So this one, we are given a conversion. We are given a different step process in order to solve for pounds in this case. So we're no longer solving for weight in newtons, we're solving it in pounds. So given that 1 kilogram of mass is equal to 2.2 pounds on Earth's surface, what is Felicia's weight in pounds? So working back from our last problem, we know that Felicia's mass was what? Awesome. Her mass was equal to 45 kilograms. All right, so now let's write down this conversion because it's the one thing that we are given in this problem. So 1 kilogram is equal to 2.2 pounds. But we're given 45 kilograms. So how much would that be in pounds? Well, all you need to do is take your 45 and multiply it by 2.2, and you're going to find Felicia's weight in pounds. So you take out your handy dandy calculator and you do that out. And you should get 99 pounds. Let's move on to the next one. So a baby dog is 10 newtons. What is this dog's mass in kilograms? So this one is a little bit different, right? Because we're given the weight and now we need to solve for the mass, but we follow the same procedure, right? So what are we given in this problem? Right, we are given the weight, 10 newtons there. Sweet. What is our other known, right? From our equation W equals mg, what is that other constant that we know? It is G. And G is equal to 10 meters per second squared. Awesome. So what do we need to solve for? Well, we need to solve for the dog's mass in kilograms. Okay, so M to us right now is a question mark. So we are given the equation W equals mg. So we know W, we know G, and we need to solve for M. So in order to get M alone, we just divide both sides by G. This cancels out the G's here, and we get that mass is equal to your weight divided by your acceleration due to gravity. Okay, so now we just plug it in. All right, so we plug in our knowns. So your mass is equal to 10 newtons divided by 10 meters per second squared. And remember, we said that newtons were 10 kilogram meters per second squared. So if we take that down, we know that these units are going to cancel and we're going to be left with kilograms, which is great. This is exactly what we want. So we take 10 and we divide it by 10 and we get that the baby dog is 1 kilogram. All right, let's jump to the next one here. So the force or the weight, right, of a 5 kilogram mass is how many newtons? So this one's pretty good, right? So what are we given in this problem? The mass. So the mass is equal to 5 kilograms here. Sweet. And what is our other constant? It is G. So 10 meters per second squared. And all we want to do is solve for weight. So W equals that question mark here. So now in order to solve, we just rewrite our equation and plug in our knowns. So W equals mg, and m is your mass in kilograms, which was 5 kilograms, and g is 10 meters per second squared. So now we just do 5 times 10. So your weight is equal to 50. And what are the units here? Newtons. Great, let's jump to the next one. So the force, weight, right, of a 10-kilogram book is how many newtons? Okay. Again, what are we given in this problem? The mass is equal to 10 kilograms. And what is our other constant? G is equal to 10 meters per second squared. And what are we asked to solve for? The weight. So what is our equation that we need to use in order to solve for weight? W equals mg. Sweet, now we just have to plug in our information. So W is equal to 10 kilograms times 10 meters per second squared. And we get that the weight of this 10-kilogram book is 100. And what are the units here? Newtons. Moving on to the next one, a melon's mass is 1 kilogram. What is its weight in newtons? Again, we have to start out with what we are given. So what was the mass that we were given? 1 kilogram. And what was the weight in newtons? Well, we have one other constant that we know, right? So what is that other constant? The acceleration due to gravity. Awesome. So it's 10 meters per second squared. So what is this weight? Well, the weight right now to us is a question mark. So now, in order to solve, we rewrite our equation. So W is equal to mg. And now we just have to plug in our information. So the weight is equal to mass in kilograms, so 1 kilogram times g, which is 10 meters per second squared. So now we just take 1 times 10, and we get 10. And what are the units here? Newtons. All right. Coming on to the last ones here. So an apple's weight is 1 Newton on Earth. What is its mass in kilograms? I'm going to go ahead and let you work this out on your own and type in the answer in the box here. Okay? And your physics textbook is 2.7 kilograms. What is its weight in newtons? Again, going to have you work this out on your own. Make sure you write down what is given, what your knowns are. So like, what's that other constant that we know, right? Rewrite that equation and plug in everything that you have. Then do the math. Yay! All right, so I hope this was helpful to all of you. If you have questions, please let me know. And great job, everybody.